Hello student, last lecture we have seen of uniform and non-uniform motion, circular motion. So we continue next lecture with a new topic, application of uniform circular motion. Okay, so first one, vehicle along horizontal curve road. So horizontal curve or horizontal means straight line, straight curve road. Okay, so let us see. M is the mass of vehicle. Now suppose let us see this figure. This is the mass of vehicle, capital M. W is the mg, weight of vehicle. N is the normal reaction between road and car or tire of car. N is the normal reaction between road and car and car's tire. F means frictional force. Here static frictional force. Fs is the static frictional force. Then V is the speed of vehicle. So the necessary centripetal force for negotiating curve path is provided by friction between road and tire. Okay, so let us see this figure, free body diagram. Now directions or forces acting on this body is N is directed along upward direction. So it is normal reaction between car and tire of the car and road. W is the weight of the body, means mg, always acted on downwards direction, and frictional force is directed along horizontal body of the car. Okay, so the maximum speed with which a vehicle can negotiate the curve path is called the seft speed, and if the speed is more than that seft speed value, it will skid away, that is outward. Okay, means the frictional force or static friction, it prevents the vehicle from outward slipping or skidding. So this is the resultant force, which is centripetal. This is the resultant force is centripetal force. So at equilibrium, Fc is equal to Fs, means frictional force is equal to Fs, or total force is equal to frictional force, FCFS. So Fc is the centripetal force, is exactly equal to static friction. So centripetal formula for centripetal force is mv square upon r, and formula for Fs, means frictional force, is equal to mu s n. N is the normal reaction between road and tire of the car, and mu s is the coefficient of static friction. So mv square r is exactly equal to mu s mg, because n is nothing but the normal reaction between weight of the car, and n is the normal reaction. So cancel out here. So v square upon r is equal to mu s g. Then rearranging this formula for v square, v means seft speed. So v square is equal to mu s rg. So v is equal to root of mu s rg, and this is the seft speed of the car. The seft speed. So when body or vehicle on a horizontal road, the v is equal to root of mu s rg, is the seft speed of the car. Now second application for uniform circular motion. So second one is wheel or wall of depth. We know that wall of the depth we see in a fair, correct? So this is the vertical cylindrical wall of radius small r, inside which a vehicle is driven in horizontal circle. This free body diagram is given as. So the free body, this is the vela or wall of the depth. So friction free diagram. So direction for frictional force is upward direction, and mg means weight of the force, downward direction, and normal reaction between horizontal. Okay, so let us see this figure. Now this is wall of the depth. So frictional force acted on upward direction, and normal reaction between road and tires of the vehicle in horizontal direction. This is the horizontal direction, and mass of the body acted on mg means weight of force directed along downward direction. Okay, so body is balanced, or car is balances in this wall in vertical direction. Again, see this diagram. This is showing the free diagram. So this n is normal reaction, mg is downward direction, vertically downward, and fs is acting friction is acting vertically upward. So writing this, weight mg acting vertically downward, friction and normal reaction. Okay, so frictional force is balancing the weight, and the normal reaction provides the necessary centripetal force. When body rotates in horizontal direction, so this normal reaction acted toward the center of the circle. This is circle, center of the circle. So when body is motion, then its balance is, or it continues in motion, vertical circular motion, then its necessary centripetal force is provided by normal reaction in both the applications. So here again using this balancing forces, we write down the formula. So n is equal to normal reaction, this balances the centripetal force, so n is equal to mv square upon r, or mr omega square. So mg is equal to friction, so F is less than or equal to mu n. So mg is less than or equal to mu mv square upon r. So g is equal to less than or equal to mu v square upon r. So rg upon mu, we get rg upon mu. So it is less than or equal to v square, and v is greater than or equal to root of rg upon mu. So for minimum velocity, v is equal to root of rg upon mu. So v minimum, so safety's minimum speed for the car is exactly equal to root of rg upon mu. So better understanding of well of depth equation. So we norm n is equal to mv square upon r, and mg is equal to fs. So in this diagram, because n is normal reaction, so your centripetal force is balances the normal reaction. So n is exactly equal to mv square upon r, and mg balances fs. So therefore mg is equal to fs. Fs means frictional force, nothing but mu s n, coefficient of static friction and normal reaction between tire of the car and road. So mm here, n nothing but a mv square upon r. So putting this equation value of the n, so mm cancel out, then g is equal to less than or equal to mu s v square upon r. Okay, v square upon r. So we find out here safety speed for vehicle. So rearranging this equation for v square, so v square is nothing but or greater than equal to, because it's greater than, so greater than or equal to rg, and here mu s is downward direction. Okay, so down here numerator and denominator is mu s. So we get here v square is equal to, so v minimum is equal to and it's exactly equal to square root of, because v square, so square root of rg upon s. Last equation we get v square is equal to mu s rg. Now in this equation we get square root of rg upon mu s.